Let's use the fairy tale Jack and the Beanstalk as an analogy for building data pipelines. Let's get a recap of the story first. Once upon a time, in a small village, lived a boy named Jack. Jack's family owned a farm, but it wasn't productive anymore, and his mother decided to sell their only asset, a cow, in the local market. On the way, Jack met a mysterious old man who offered him magic beans in exchange for the cow. Intrigued by the offer, Jack traded the cow for magic beans and rushed home. His mother was very upset, threw the beans out the window, and sent Jack to bed without supper. But to Jack's surprise, overnight the beans sprouted into a gigantic beanstalk reaching up to the clouds. Now let's go ahead and compare that story to a data pipeline. First up, we have planting the beans. This is like data ingestion. Just like how the magic beans are planted into the soil, the data ingestion is the process of importing, transferring, loading, and processing data for later use in storage or in a database. Jack's act of planting the beans can be like this particular process. Next step, we've got the growth of the beanstalk. Data processing is a very similar scenario. As the beans grew into a giant beanstalk, the data also needs to go through a transformation process. In the data processing, raw data is cleaned, it's validated, it's aggregated, and it's summarized to provide meaningful and high quality data. Next up, we've got the climbing of the beanstalk. This would be the data movement. Jack's adventure of climbing up the beanstalk is similar to data movement. It involves transferring data from one location, condition, or format to another. In a pipeline, this would involve moving data from one storage platform to another or from the cloud to the edge. Next up, we have the giant's castle. This is data storage and analysis. The giant's castle in the clouds has treasures, and this is similar to data, right? There's data that you need to do things with, and you need to store it, manage it, analyze it, look for insights. This is like discovering something useful, just like Jack is discovering the giant's treasures. Finally, in the last step, we have Jack's return, which is data visualization and reporting. Finally, Jack is triumphant and returning to the village with the treasures. And this symbolizes data visualization and reporting because you can get this feedback and make it in a usable form and make data-driven decisions. This is a lot like Jack sharing his wealth with his mother and improving their lives. So just like the adventure with Jack of the Beanstalk, a data pipeline is an exciting journey for data, and it takes raw data, transforms it, and turns it into valuable insights, enriching the decision-making process of a business. And in a data-driven world, they lived all happily ever after. Let's take a look at the common data engineering tools that are used in industry with a focus on open source here. To start off with, we have the Hadoop, Spark, Hive ecosystem. And first, let's look at some of the pros here of these particular tools here. Scalability, you can use these to handle large data. Also, flexibility, you can process a wide variety of data types and structures, including semi-structured or unstructured data. Cost effectiveness, you can use commodity hardware, and also integration. So you can use things like SQL to get things done. In terms of the cons here, there is a little bit of complexity that you have to deal with. That's one of the issues with these tools. Latency as well is another issue here in terms of not knowing how to deal with real-time processing data. This is something that you have to actually work around. And then resource management, it can be very difficult to, get everything working exactly the way you want it. And then maintenance, right? If you're dealing with these systems, they require a lot of, hand-holding and maintenance and the ability to make them run at a scale that you actually are able to keep it in operations. Now, in terms of being here as well, one of the things that's important about the pros is that it is a unified model, right? So what this means is that you can use pipeline for batch streaming and also combine different workloads. It's also portable, so you can use it on lots of different run times like Flink or Google Cloud Dataflow or Spark, etc. And also has support for multiple languages. meaning that you can use Go, Python, Java, etc. Now, in terms of complexity, though, this is one of the downsides of Beam. Also, limited adoption. There's not as widely used runners, for example, with Beam, and then the performance can also be an issue because it's not as optimized as a dedicated batch or stream processing system for certain use cases. Now, what else do we have here? We also have Airflow, which is also a very common tool that we can learn about. And in terms of Airflow, one of the things that you can be aware of is that they have workflow management. In terms of a pro, it's got powerful tools for defining and executing and monitoring complex data pipelines, scalability as well. So it has great scalability characteristics. And then in terms of the community and ecosystem, there's a ton of things around the Airflow ecosystem. But the cons would be that the learning curve is very steep for this particular system. The deployment and maintenance can also be an issue in terms of a distributed environment, and then the UI may not actually be exactly what you're looking for in terms of a managed workflow orchestration. So next up here, we can also talk about the pros and cons of both Kafka and RabbitMQ, and in particular here, a few of the things that we can care about would be that in terms of high throughput, scalability, fault tolerance, they have the ability to really handle tremendous amounts of data. These are some of the strengths with these particular systems for real-time message exchange. In terms of the cons, though, maybe one of the things that could be an issue is the message handling, right? Can you actually figure out how to process orders efficiently? And in a particular, delivery system, you could have some issues there with things being out of order, and also delayed message handling as well could be an issue. And then, as usual, resource management could also be a con to be aware of. Now, what else do we have here? We also have Cassandra, and one of the things that's important about Cassandra as a pro is that it is actually very scalable, right? So it's designed to do distributed, NoSQL. In terms of the flexible data structure as well, we can see that it has the ability to do, semi-structured data, structured data, etc. But also in terms of the cons, is extremely complex to use. And also, if you have a write-heavy workload, that's great. But if you don't, then you could run into issues with, let's say, a read-heavy workload, and this could be something that could be a problem. And also, the lack of aggregation could also be an issue for this. So, just again, in terms of looking at the pros and cons of these approaches, it's important to know that there is no one perfect solution for everything you're doing with data engineering, although these are very common tools that you will see in industry. Here we have a data engineering pipelines diagram where I've been able to whittle things down to really three different components of a data engineering pipeline. First up, we have data ingestion. Second up, data processing. Third, data storage. So these are really the uniform aspects of a data engineering pipeline that are always present. The orange items here, resilience, scalability, monitoring, these are components that are really persistent and that they're going to be a part of any data engineering pipeline that goes into production. So let's go ahead and talk through each of these components. So first up, in terms of the ingestion, this is the most important part of a data pipeline. Really, it's can I get anything to work? And the data can come from multiple sources. It could be a database, a data lake, or even real-time data streams. And it's going to be able to process that data from a collection standpoint. Next up, we have processing, and this is about transforming the data into a more usable form. This could be cleaning or validating or formatting the data, and it makes sure that you can actually build aggregations, summarizations, etc. So this is where we see a lot of tools like Spark, for example, that can go through and do processing and other ETL type operations. Now, in terms of the final step here, which is the data storage and output, This is where the pipeline would facilitate storing the process data in a suitable manner for further analysis. So it could be, for example, a data warehouse, or it could be a dashboard, etc. This is the final endpoint. Now, along the way, though, we have these other components here. And so scalability is something that's really critical, because in terms of building something that's able to run in production, you have to be able to run it at a vertical or horizontal scalability, and this means that you can add nodes to it or increase the size of the system. And then in terms of the resilience here, this means that they're able to run even if there's an error. So, for example, if it's an event that triggers it and there's some problem with the event, it could still alert you and tell you what the issue is, or it could maybe have different nodes that are running, and some of the system can run even though one of the nodes has actually failed. Also, in terms of monitoring and maintenance here, we have the ability to look at the data flow, look at the system performance, maybe send out an alert when there's some kind of an issue with the pipeline. So, really holistically, when you're thinking about data engineering pipelines, these are going to be the key components, right? Step one, data ingestion. Step two, data processing. Step three, data storage. And then these inherent principles, resilience, scalability, and monitoring, are always present, not only just in data engineering pipelines, but also in production software engineering systems.